arithmetic sequences or arithmetic sequences, whichever way you want to pronounce it. 3-6. Okay, a sequence is an ordered list of numbers or objects, and each part of a sequence is called a term. So these are all terms. This is one sequence. This is a different sequence. This one has terms. So this has 4 terms. That has 5 terms. That's pretty easy. What makes it an arithmetic sequence is it has something called the common difference. The common difference. The common difference is either a positive or negative number representing plus and minus that tells you what's happening in between the terms in the sequence. So what's happening to go from 7 to 10? Well, plus 3. What's happening to go from 10 to 13? Plus 3. What's happening to go from 13 to 16? Plus 3. So, if you were given this sequence and you were asked what's the common difference, you would say plus 3. That's the common difference of that sequence. Okay, look at the next sequence. What's happening from 10 to 8? Minus 2. What's happening from 8 to 6? Minus 2. What's happening from 6 to 4? Minus 2. From 4 to 2? Minus 2. So what's the common difference of this sequence? Minus 2. You must have the plus sign or the minus sign on these answers, or it would not count. You have to tell what's happening in the sequence. Is it adding something or subtracting something? Sometimes you might be asked to find the next 3 terms in a sequence, or a missing term if one was left out in the middle. You should be able to figure out the other terms in the sequence by finding the common difference. So, let's find the common difference first. What's happening from here to here? Well, negative 12 plus 8 is negative 4. And negative 4 plus 8 is 4. And 4 plus 8 is 12. So, the common difference is plus 8. So how do I find the next term? I say 12 plus 8 is 20. And the next term after that would be 28, because I'm adding 8. And the next term after that would be 36. So when it asks you to find the next 3 terms or find the missing term, because they could have a whole sequence and have some blanks in it, some missing terms, that's how you figure it out. You find the common difference, figure out the missing numbers or the next 3. Okay, now on this problem, which is going to be quite like a lot of the problems we're going to work, the directions are super important. Because the directions, even though you look at them and you're like, what does that mean, are the thing that tells me what I'm really going to do. So when it says find a function that describes each sequence, find a function that describes a sequence. When it's worded that way, and then it gives you a problem with some values, it's telling you that these are the y values, always. Okay? Now, since it's a sequence, the x values, and by the way, the book is going to use the letter N for x, I just use x. The x values are always going to be in sequence, so they're going to be 1, 2, 3, 4. It's what it's saying is, this is the first term in the sequence. This is the second term in the sequence. This is the third term in the sequence. This is the fourth term in the sequence. So, when you do an input-output table on this type of problem, these are the y values. You don't have to find them. They gave them to you. So you got the 2, the 4, the 6, and the 8 here. And then they're saying 2 is the first term, so that's 1. 4 is the second term. 6 is the third term. And 8 is the fourth term. So the x's always start at 1 and go up. because it's talking about what term number. Now, that's basically the first part. Let me erase the screen and we'll continue. Now, remember, this is the problem that says find a function that describes a sequence, important directions. So all I've done, and these are our y values. They give us the y values. We always use 1, 2, 3, 4, and so on for x. So all I have done is spread out our input-output table to give it a middle. I need a middle to figure out what the function is. Because remember, functions are described by an equation. So we're looking for an equation. That's going to be our answer. Y equals something. We're trying to figure out what equation goes with this table. Okay, so I spread it out to make it easier. How can you get from 1 to 2? And 2 to 4? And 3 to 6? And 4 to 8? What's happening from the x to the y? Well, what's happening is x times 2, because 1 times 2 is 2, and 2 times 2 is 4, and 3 times 2 is 6, and 4 times 2 is 8. So x times 2 is what's happening. If we're writing that in an equation, we would write 2x, wouldn't we? So the equation that goes with this is y equals 2x, and that is our answer to this problem. We are looking for an equation that goes with it. Let's do another one. Remember, these are the directions that say find a function that describes each arithmetic sequence. Find a function that describes a sequence. That means these values that they have given us in the problem are y values. So we're going to make our input-output table. Remember to make it a little bigger with a middle. And we're going to put our y values in, -3, -6, -9, -12, and our x values, which are always going to be 1, because this is the first term, 2, because this is the second term, 3, because this is the third term, 4, because that's the fourth term. And now we want to figure out what's happening to get from 1 to -3 and 2 to -6. What's happening in the problem to x to give us this y? That's what we're trying to figure out. So let's see. 1 times -3 is -3. 2 times -3. They're multiplying by -3. So I'm going to say x times -3. So 1 times -3, that's right. 2 times -3, that's right. 3 times -3, that's right. 4 times -3. I'm checking it out to make sure it works. So I need an equation. It's going to start with y equals. What do you think? Could it be y equals -3 times x? Because then when I put 1 in for x, I would get -3 for y. That's the equation. Let's do another one. Here's the next one. Remember, these are the directions that say find a function that describes each arithmetic sequence. Find a function that describes a sequence. The only way you know to do this is from the directions. When it says that, it means these are the y values. So I'm going to make my kind of spread out input-output table. Put my y's in, 2, 6, 10, 14. Put my x's in, which are always going to be 1 for the first term, 2 for the second term, 3 for the third term, 4 for the fourth term. Now, remember, I'm trying to find an equation. So I need y equals something. That's what I'm looking for. So I've got to figure out how I can go from 1 to 2, 2 to 6, 3 to 10, 4 to 14. Now, I'm going to tell you ahead of time, this one's a little different than the ones that we've had. Because every one we've had so far has been like y equals 2x, or y equals 3x, or y equals negative 4. You know, it's always been one like this with nothing over here. This one is going to have some stuff on the other side. This one is going to come out like y equals 2x plus 2, or y equals 3x plus 7, or something with a plus or minus thing. So we got to be aware of that. When you can't just right away see what's happening, you have to say to yourself, oh, wait a second. Maybe this is going to be one of the harder ones. So here's how I want you to proceed. Okay? I want you to do, if you can't immediately figure it out, then you need to do some trial and error. So you need to try something like, okay, if I use x plus 2, would that work? Always look at this first one, see what works for that, and then try it out on the second one. Well, if x was 1, 1 plus 2 would be 3, so that doesn't work. Try something different. What if I did x plus 1? Well, 1 plus 1 is 2. That works for that. Will it work for 2? 2 plus 1 is 3. Nope, won't work for that. So when I've sort of ruled out that it's a plain x, then I'm going to try for 2x. And I'm going to say, well, 2 times 1 would be 2. How could I get to 2? Well, 2x would only work if it was no plus or minus thing over there. But 2x does not work for this one. 2x works for would work for the first one, but 2 times 2 is 4, so that wouldn't work for the second one. So it can't be 2x. So I'm going to quickly move up because, you know, sometimes it's 7x, and sometimes it's 5x, and sometimes it's 4x. So I'm going to try 3x. 3x, if I went 3 times 1, that would be 3, minus 1, that would give me 2. So 3x minus 1 would work for the first one. Will it work for the second one? Well, 3 times 2 is 6, and minus 1 is 5. That won't work for the second one, so it can't be 3. See how I'm eliminating? I'm going up. Let's try 4x. Okay, 4 times 1 is 4, minus 2 is 2. So 4x minus 2. That works for the first one. Does it work for the second one? Well, 4 times 2 is 8. 8 minus 2 is 6. I'm starting to get excited because 4x minus 2 works for this one. Does it work for the third one? Let's see. 4 times 3 is 12. Minus 2 is 10. Okay, it's working for the third one. Does it, in fact, work for the last one? 4 times 4 is 16. Minus 2 is 14. Yay, I found it. 4x minus 2 works for everything on this chart. So the answer, the function, the equation is y equals 4x minus 2. I found a way to figure it out. Super cool. Okay, here's part 1 of video homework. Stay tuned for part 2. Here's the second part of video homework. Have a lovely, beautiful evening. Good night.